right, so as a quick refresher, three things we learned yesterday was that if you have a right triangle, all of it started this way. If you have a right triangle and the altitude is drawn to the hypotenuse, the first thing is that it makes two triangles that are not only similar to each other, but also similar to the large triangle.
Wait, did we already finish the quiz with all the...
Well, I'm going over what we did for 9.3. So 9.3 was that they're similar to the two smaller triangles are similar to each other and to the big triangle.
No, what I'm trying to say is it was 9.3, the last chapter.
Yes, yes, your quiz is 9.1 to 9.3. Then we did the one where if the altitude is drawn towards the hypotenuse, then we came up with two ratios. The first, or proportions. The first was that segment 1 over the altitude equals the altitude over segment 2. And the second is that the hypotenuse of the big triangle over the leg, and there could be either leg, but whatever leg you use there, you have to repeat over here, over the segment of the hypotenuse adjacent to the leg. So depending on what is given, you might have to use both of those proportions, like some of the questions in the homework, and then sometimes you only need one. If you are given information about the altitude, then obviously I'm using the first one. If I have no information about the altitude, but I have information about the hypotenuse and the leg, then I'm using the second one. So you kind of got to look at them and figure out from there which ones you're going to do. So the first question, and it will be a question on your quiz, is to identify the three similar triangles in the diagram. So if I start with the big one, and remember that the order of the letters is important. So if I go alphabetically with the first one, X, then Y, then Z, I went shorter leg to longer leg, right? So I have to follow the same pattern for the other two. So if I'm looking at the triangle on the left, what's the shorter leg into the longer leg?
Short leg to longer leg.
X.
Y, X, W.
Nope. X.
Y, W.
Nope. X.
W, Y.
W. Y. Shorter leg into longer leg, right? Because that's the order I put it in for the other one. Then I'd look at the triangle on the right, and I have to do the same thing. So how do I name it so that its shorter leg leads into its longer leg?
XW?
No, the blue triangle. Y, W, Z. Shorter leg followed by longer leg. That should be an easy question, you guys. Got to be really careful. Yep.
Those are the easy
Start
ones
with
on
a different triangle, then
So it's actually multiple choice. You'll pick which one you want based on it. That question is multiple choice.
I did ZWY.
So you named ZWY. So you went this way. So then it should have been YWX
Yes.
and ZYX.
Yes.
Then that's good. Which is why it is multiple choice, because there's a million different combinations you can come up with there. All right, 2, from this diagram, which of those two proportions should you be using? Mars,
Oh wait, what do you mean proportion?
like which of these would you use?
Oh, you do the segment 1.
Good, because you have an X on an altitude, right? So whether there's a value on the altitude and you use it, or there's a variable on the altitude but I still need to use it, then that's the one I'm going to pick. So segment 1 over altitude equals altitude over segment 2. Does it matter which one I make segment 1 or segment 2? No. So it could be 9.
Equals X over 5.
Good. Cross multiply. I get X squared equals.
Equals 45.
You could multiply it out, but I'm just going to end up square rooting it, right? So save yourself the step.
But what did you mean 3 times square root of 5?
Yep. The 3 comes to the outside. Square root 5.
That's what I got. So good.
Good.
Wait, you can't do that. One of them is squared, right?
Right. So then you would just break it down into into a product of its primes. All right, now 3, I have nothing on my altitude, right? What I do have a variable on is the leg of this triangle, so I use the second one. You want to set it up, Jonathan?
Yeah.
Hypotenuse is what?
Okay.
No, it's hypotenuse of the big triangle. 10 over the leg. A, leg repeats. Segment of the hypotenuse adjacent to the leg? 6.
I did the other one. I did A equals the square root of 6 times 10.
What?
That was in the notes.
What? What? What?
A equals the square root of 10 times 6.
Yeah.
Yeah.
Let me finish this the right way, and then we can go over whatever it is that you just said. 2 square root 15.
You make
That,
I made it up.
Yes.
that is what you should have gotten for 3.
I.
So in class we did these using the ratios, or the proportions and we gave a variable here, but we gave a variable here and then we set it up. But the easier way to do these is using the similar triangles, setting up a scale factor. So because we have the side lengths for all 3 of the big triangle, and then we have 1 for this smaller one, we can set up a scale factor. So on the smaller one, the one you have is the hypotenuse of the smaller one. So that 7 would go over the hypotenuse of the big triangle, which is 25. And then that's your scale factor. So if you're trying to find what x is, x would be the middle length side of the small triangle. So it would go over the middle length side of the large triangle, which is 24. And then you can cross multiply. So 7 times 24 would equal 25 times x. 7 times 24 is 168. And then you would divide both sides by 25. So x is 168 over 25. All right, this one, again, you've got different parts. You've got some legs missing, you've got hypotenuse missing, right? So the easiest way, I think, is to use the bottom right triangle. All right, 12 squared plus 16 squared equals z squared. So 144, 256, 400, and the square root of 400 is 20. So now I get that one. Now you've got choices because you can use hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. Or you could, by doing it x plus 16, so I could do x plus 16 over 20 equals 20 over 16. I could do it that way, right? Or you could do segment 1 over altitude equals altitude over segment 2 using these 3. I think that's easier. X over 12 equals 12 over 16. So then 16x equals 144, and 144 divided by 16 is 9. Now I got that one. And now I can do this triangle. Again, complete this. I can either use Pythagorean theorem or I can use hypotenuse over leg, which would be 25. 25 over y equals y over 9. Y squared would equal 9 times 25, which should be 3 times 5. I mean, that was not like so off the charts. The other ones were harder when you had like fractions that you were subtracting, that kind of stuff. But I don't feel like this. 1, they're all whole numbers. 2, it's a mix of Pythagorean theorem. And then the other ones, I don't know that that is so far off the charts.
The one
Yeah.
was like one of the answers was like 128 over 3.
Yeah, probably not. Probably not going to be that ugly.
I had it right, but I got it wrong because I gave it.
All right, this one. What are you going to do?
Wait, I don't.
Pythagorean theorem. Nope.
Altitude
How do you, wait, why would you?
Well, how do you know? Like, what tells you to use the altitude one?
Because you got the altitude.
Because there's a value on an altitude, and there's not a value on a leg, right? So,
It's
A plus 5.
12 equals the square root of 18 times a plus.
Jonathan, you're going to confuse everybody because you're doing it different. A plus 5 over 12 equals 12 over 18. You're not wrong, but you're going to confuse everybody. So then I would actually simplify this. 6 goes in here twice and 3 times. Did you just pretend to throw something at me? Uh-huh, I saw it. Uh-huh. I have mom eyes and ears. I can see everything, and I hear things I don't want to hear.
I was trying to throw something.
Yeah, I can hear you. 3, I can still hear you. A is 3.
Why is it like so easy when
Because I know the answer.
This was the correct answer, right?
All right, which one would you use for this one? Why do you know to use that one? There's nothing on the altitude, right? So hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg, which I don't have, but could figure out by doing what?
8 minus 2?
8 minus 2 is 6. X squared equals 8 times 6, square root Don't multiply it and then have to break it back down. Just keep going. That's 2. That's 2. The 3 stays underneath. So that's an example of something like that would be kept exact, obviously. You're not going to have a calculator. You would keep it as that square root 3. You wouldn't approximate it. So this one, the x is here. This is the same scenario as before, right? You could set up your scale factor if you wanted to, so we can do one that way since the big triangle has all 3 side lengths. The smaller triangle on the right has the hypotenuse. So if I wanted to set up a scale factor, it would be 26.3 to 12.8. That's big side to big side. Then you can reduce it from there, and you could set it equal to the x is the middle length side of the smaller triangle. So that would go on the bottom, and the middle length side on the big triangle is 23. That would go on the top. And then you could cross multiply from there. So that's how you could use your scale factor instead of having to do hypotenuse over leg and then use it again. Mars.
This one's not the same one as 18 I did.
For this question, you're looking for the altitude. You're given the hypotenuse, but you're not given either segment. So this is when it's easier to fall back on your similar right triangles. The big triangle, you have all 3 side lengths, and the small triangle, you have that hypotenuse. So hypotenuse of big triangle is 34, hypotenuse of small triangle is 16. And then I'm trying to find the middle length side for the small triangle. So the x goes in the bottom. The middle length side of the large triangle would be 30. You can actually reduce this. This would be 17 over 8, at least working with smaller numbers here. And then 17x would equal 240. And divide by 17, and x would be that 240 over 17. Okay, number 5, we have the hypotenuse. Again, you're looking for the altitude, but you don't have either segment, so this falls back on the similar right triangles. The 15 is the hypotenuse of the small triangle, so 15 would go over the hypotenuse of the big triangle, which is 39. And that would equal the x is the longer leg or the middle length side, which would go over the 36 of the big triangle. 3 goes into both of these. This would be 5 over 13, and then I'd get 5 times 36 equals 13x. And 5 times 36 is 180. And then I would divide both sides by 13. And x equals 180 over 13. Okay, so as a reminder, topics covered on the quiz, this is 9.1 to 9.3. 9.1 was the original Pythagorean theorem, which is a squared plus b squared equals c squared. I'm missing the e there, sorry. And then the converse, which is how we classified acute, all those. So if c squared equals a squared plus b squared, then it's right. If c squared is less than a squared plus b squared, then it's acute. And if c squared is greater than a squared plus b squared, then it's obtuse. In 9.2, we did our 30, 60, 90, and 45, 45, 90 triangle. So 30, 60, 90, the side lengths were opposite the 30 is a, opposite the 60 is a root 3, and opposite the 90 is 2a. And then in your 45, 45, 90 triangle, which is the isosceles right triangle, it's a, and a root 2. So opposite each 45 is the a, opposite the 90 is the a root 2. And then we finish up with what we started today with, which is 9.3. We have our similar triangles. So every right triangle with an altitude is drawn to it is similar to itself. Is similar to the 2 smaller triangles and the large one. Like question 1 from the warm-up. And then segment 1 over altitude equals altitude over segment 2. And hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. Have a great day.